look at when we're adding fractions are the denominators. We got to ask ourselves, are the denominators the same? And in this case, yeah, they're the same. They're both 5, right? We have 1/5 plus 2/5. So being that they're both fifths, our denominators are the same. So there's not much to do here. Our answer is going to have the same denominator because they're already the same. So our denominator and our answer is going to be 5. And then we just look to the operation, the addition, and we add the numerators. Okay? So we add 1 plus 2, and that's 3. Again, remember, I can only add the numerators when the denominators are the same. Unfortunately, a lot of our problems don't look like this. We don't really see too many addition of fractions where the denominators are automatically the same. But if they are, it's real easy because they're already the same. You just add the numerators and the denominator stays the same. Okay? Now, I put over here in the top right of your screen, I put this is my answer proper and is it in its lowest terms. We always need to make sure that our final answer, that we go through this little checklist right here, these little two checks that we got to make sure. It doesn't matter if you're adding, subtracting, multiplying, dividing, whatever your final answer is, in whatever operation of fractions you're doing, you need to check these two things all the time. Okay, so the first thing, is it proper? That means, is the numerator smaller than the denominator? Yes, the 3 is smaller than 5, so yeah, it's proper. Is it in its lowest terms? Yes, they're both prime numbers. They can't be reduced by anything else other than themselves. So that means that I can't reduce the 3 and the 5 by the same number. Okay, if you don't understand that, go back to the reduction video where I was reducing fractions. Okay, so yeah, this is my it's proper and it's in its lowest terms. So yeah, that one's done, easy. But let's go to the one that's more common, the type of problem that's more common when we're adding and subtracting fractions, and that is when the denominators are not the same. So I'll go ahead and change this fraction down here. Okay, we'll leave the top one. We'll leave the 1/5. But we'll change the bottom one here. We'll go ahead and put, let's put 1/3. Okay, 1/3. So now I can't add these fractions the same way I did the last time because the denominators are not the same. So I need to find a common denominator, and preferably the lowest common denominator, okay? So in order to do this, the idea here is to be strong with your multiplication tables so that you don't need to do it by hand. I'm going to show you here in this little space right here, I'm going to show you how to do it by hand. But ideally, this is what you should try to be doing in your mind, okay? So let's go ahead and do this. So I'm going to go ahead and put the two denominators. I have a 5 and I have a 3. I'm going to go ahead and put 2 lines just to separate the 2 rows. Okay, this is not like a fraction bar. Don't get confused with the fraction. I'm not trying to do that. I'm going to be counting by 5 and I'm going to be counting by 3. Again, this is your times tables, okay? So if this is difficult, you got to get stronger with your times tables. Absolutely, that's where the problem might be. So let's count by 5. Why am I counting by these numbers? Who cares, right? Why am I doing this? The idea is that if I count by 5 and I take that sequence of numbers out far enough, and I take the sequence of 3's out far enough, eventually I will have a number that is the same in both sequences, a common number or a common denominator. Okay, so let's go ahead and start counting by 5. 5, 10, 15, 20, that's a terrible 20, 25. Okay, I'll stop there. Let's count by 3. 3, 6, 9, 12, 15. That's actually where I need to be, right? I mean, I have a common denominator. That's my first one that's the same in both sequences. If I was to take this sequence out further, I would find another common denominator when I would hit 30. Okay, or any factor of 15 in that case, okay? So, but I want to use a smaller one. We'll pick 30 later. I'll show you one with 30, okay? But we'll pick the lowest one. So, I'll put my new denominator, my new lowest common denominator, next to each fraction, okay? And I'll put my little boxes. Okay, I need my little boxes. And what I ask my students, because later on you'll see problems with proportions and other things like that, and I explain it very similarly, so I'll just go ahead and teach you guys that now too. I ask my students, is the 3 getting bigger or is it getting smaller? Right? And in this case, the 3 is augmenting to 15. It's getting larger. So what operation is that? You could say addition, but really for us, in this case, it's going to be multiplication, okay? So my clues in my denominators, if it's changing from a 3 to a 15, that means it's getting bigger, and that's going to be multiplication. So at least I know, well, I need to multiply 3 by some number to give me 15, okay? And that number is 3 times 5. And I'm going to repeat that. That's why I use my box. So I write my number 2 times, my little factor of 5. I can write it 2 times and I don't get mixed up. It helps me keep my information organized, okay? So 1 times 5 is 5. And I'll do the same with the top one. 5 is getting bigger, that's multiplication, so they'll both be multiplied. 5 times something is going to give me 15. That number is 3, or that factor is 3. So 1 times 3 is 3. Ta-da! Now we have the same denominator in both. Okay, so now I can put my denominator, my common denominator, in my answer. And now I just do my operation, in this case my addition, with the numerators. 3 plus 5 is 8. Okay? And that's essentially it. Now again, I can't put my stamp seal of approval on this until I go through my two boxes, my little 2 checks here, before I can say I'm done 100%. So I'll erase these little checks and then we'll do it again here. So can I reduce is it proper? Is this fraction proper? Yeah, the numerator is smaller than the denominator, so check. Proper, almost there. Lowest terms, can this fraction be reduced by anything? Can it get smaller? And if you haven't seen that, check the video with how I was reducing fractions. And when you do, you'll notice that this is in its lowest term. So it's also in its lowest term. Okay? So that's essentially it. Now, let me show you why we want to be picking the lowest common denominator, because I sometimes have students that don't do all this, but they know that 5 and 3 go into 30. Boom, so they just pick 30 off the top of their head right away, right? So I'll just go ahead and do an example like that with 30. Okay. So what's going to change are these things. Our factors are going to change on the little boxes. Okay. So let's say we pick 30. Oops, and I got to erase my numerators. Those are going to change too. Okay. So same thing. I'm going to leave a little multiplication because 3 is getting bigger and it's going to 30. 5 is getting bigger. It's going to go to 30. So 3 times something gives me 30. That's going to be 10. 3 times 10. I use that same 10 for the numerator. 1 times 10, 10. Okay? And 5 times something gives me 30. 5 times 6 will give me 30. And I use that same one in the top one to do my numerator. So 1 times 6, 6. Okay? Now I have my common denominator. So they're the same in both. So that means I can put my denominator down here on the bottom. And then I can add the numerators. So 6 plus 10, 16. Now I would say I'm finished. However, I do need to always go back to my little boxes here, my little checklist. Mentally is ideal, but if you need to write it down so you don't forget. Is this fraction proper? Yes, it's proper because the top number is smaller than the bottom number. The numerator is smaller than the denominator. So I'll put my little check. Yes, it's proper. We're halfway there. We're almost done. So is this in its lowest terms? No. If you remember from my reduction video, my reducing fractions video, the first thing I look for is to see if the numbers are evens. And yeah, they're both even. So 16 is even, 30 is even. That means I can reduce at least by 2. So we'll divide both of them by 2. 16 divided by 2 is 8. Let me take away these 3's and 6's and stuff. Okay. And 30 divided by 2 is 15. And this is the answer we had before. And again, it doesn't matter which denominator or common denominator you choose, but if you pick the lowest common denominator, you will have less reduction at the end. If you remember when we did the one with 15, we got to this answer directly. Now when we picked the larger denominator, we actually had to reduce our answer. Now just because you pick the lowest common denominator when you start these problems, it doesn't mean that you're not going to have to reduce. It just means that you'll have less to reduce, or maybe you'll be finished.